So basically we're talking about treating sepsis. Now what is sepsis? Sepsis is a situation in which there are live bacteria, dead bacteria, or particles of dead bacteria free in the bloodstream. And it's a combination of this situation where you have these bacteria in the bloodstream and the body's response to it, which is the systemic inflammatory response syndrome, or SIRS. The body's response in this situation is quite destructive, and it can lead to a situation of multiple organ dysfunction, MOD, which ultimately leads to death. How is this mediated? This is mediated by what is known as inflammatory mediators. The primary inflammatory mediator of which is known as tumour necrosis factor alpha, or TNF-alpha. Now, I want to talk about the importance of E. coli antibodies in the body in general, whether they're put there by vaccination or whether they're put there by a plasma transfusion. And the way I want to address this initially is by looking at the scientific literature and giving you a quick summary of articles that appear in the scientific literature. Firstly, if there's a good level of E. coli antibodies, it is in the bloodstream in rats, it has been shown that it just prevents sepsis. Can't get much plainer than that. And that's a very important thing. Secondly, in mice, it has been associated with an increased rate of clearance of gram-negative bacteria from the bloodstream of mice. There's been a reduced economic loss in dairy herds from coliform mastitis in cows. It provides cross-protection to other bacteria, and this is really interesting. Species such as Staphylococcus, Pseudomonas, Klebsiella and Serratia, antibodies to E. coli all cross-protect to those bacteria. It correlates to higher survival rates in cases of sepsis in humans. Correlates also to improved outcomes and long-term survival in human cardiac surgery cases. And it also correlates inversely to the severity of acute pancreatitis in humans. Therefore, the more E. coli antibodies that are present, the less severe acute pancreatitis is in humans. And I think we'll all agree that that's a very serious illness. It also correlates to improved outcomes in experimental polymicrobial intra-abdominal sepsis in mice. So you can see a pattern here of these E. coli antibodies and how good it is to have E. coli antibodies present in these disease states. So what does the literature say about the importance of E. coli antibodies in our products? That's just a general picture across the species, human, that I've been talking about so far, experimental animals and pigs. But what does the literature say about the importance of the antibodies in our product, Equiplas E? Firstly, we've done some laboratory experiments with tissue culture of mouse fibroma L929 cells. And if we protect the tissue culture with some Equiplas E and then flood the tissue culture plates with TNF-alpha, we get less cell death in the protected plates than what we do in the plates that do not have Equiplas E present. TNF-alpha is extremely toxic to these mouse fibroma cells, and it's a very simple experiment to measure the live and dead cells, and this has been published. It also, according to Simon Peake, increases the survival rate in septic and critically ill foals that were admitted to his university clinic. It blocks TNF-alpha in a low-dose endotoxaemia model in horses. I want to talk about this later. But Forbes, Grace Forbes down at the University of Melbourne did some sponsored research for us, and the outcome was that horses that were pre-treated with Equiplas E before infusion of endotoxins had a much lower rate of production of TNF-alpha than horses that weren't. Now this, I will point out at this stage that this same E. coli vaccine that we use here on our donors in Australia is also being used on our plasma donors in California for the production of Equiplas J in that country. I'll talk about that a bit later. Our vaccine is ideally suited to produce antibodies in our donor animals that ideally neutralise the toxins produced by endotoxaemia. So What I want to discuss now, therefore, is with Equiplas E, we will have, the product has a guaranteed quantity of antibodies to LPS or endotoxin or E. coli cell wall extract, all the terms are interchangeable, of 5 micrograms per mil minimum. We have developed a novel ELISA test that will measure the actual LPS antibodies in Equiplas E, and the product is not passed for release to you, the veterinarian, unless there's a minimum of 5 micrograms per mil of anti-LPS antibodies present. So how does Equiplas E combat endotoxaemia? Firstly, it has a direct antibody action against the E. coli endotoxins, and also, as I've illustrated previously with the in vitro experiments with the mouse fibroma cells, it actually downregulates TNF-alpha, tumour necrosis factor alpha. How does it do that? Either by direct antibody to TNF-alpha, or there are soluble receptors in the horse plasma, and that is yet to be elucidated. But it definitely, by these experiments, it definitely downregulates TNF-alpha. And the experiments I refer to are the mouse fibroma cells in tissue culture and the Forbes paper using the low-dose endotoxin challenge model. I'm going to discuss that a bit later. So by reducing the release of TNF-alpha from the activated macrophages, these animals are able to do better clinically. And I'll go into the treatment regime in a moment.